Hi everyone, today we're going to be talking about exponential functions. We're going to graph and write and recognize an exponential function. In the past, we've written primarily linear functions where we see y equals mx plus b, where m is our slope and b is our y-intercept. An exponential function looks like this: y equals a times b to the x. There are some similarities. In this case, our a is our y-intercept. So when x is 0, this is where our graph would cross the y-axis. b is our factor of change, and it's a multiplication factor of change. That's what factor means. And our x is our exponent. So let's take a look at this. I have y equals 10 times 2 to the x power. So in this case, my intercept, as I said, will be my 10. It's right here. That's my y-intercept. When x is 0, my y will be 10. And you can see that because 2 to the 0 power is 1. 1 times 10 is 10. Now let's put in some other values. If I put a 1 here for x, 2 to the first power is 2 times 10 will give me 20. If I put a 2 in here for x, 2 to the second power is 4 times 10 will give me 40. And you can see what we mean by factor of change, constant factor of change. Notice that this is being multiplied by 2 each time. That's my change. Times 2 times 2. My next one, when I multiply by 2, will give me 80. Times 2 again, 160. If I were to graph this, sorry, my y-intercept is right here at 10. So when x is 0, y is 10. Go over 1. I'm going to go up to 20 for my next point. Over 2, up to 40. Over 3 to 80, which I think is here. And my 160 is going to be way up here off the graph. And you'll notice that it's a curve and it goes up quite rapidly. Let's look at my next one. I have 10 times 1/2 to the x power. Again, my y-intercept is 10. That's where my graph will start, at 10. If I put a 0 in here, 1/2 to the 0 power is 1 times 10 is 10. If I put a 1 here, 1/2 to the first power is 1/2 times 10 would give me 5. If I put a 2 in here, I would get 1/4. 1/4 times 10 is 2.5. And again, you can see your pattern. Your constant factor of change is times 1/2. 5 times 1/2 is 2.5. 2.5 times 1/2 is 1.25. 1.25 times 1/2 is 0.625, etc., etc. So if I were to graph that, I've already graphed my 0, 10. I would have 1, 5, 2, 2.5, 3, 1.25, 4 would be 0.625, and you'll see that this curves downward. Hopefully I can draw a nice line. Well, it's not a line, it's a curve. And it'll keep getting closer and closer to that x-axis, but it will never touch it. My first graph is an example of exponential growth. It's growing exponentially fast. My next one is exponential decay. You'll notice it's decreasing. Clear my screen. So let's take a look at this next one. I'm going to graph it. My starting point is, oops, I forgot my pen, 0.25. And my factor of change is 3. That means I'm going to be multiplying by 3 each time. 0.25 times 3 is 0.75. 0.75 times 3 will give me 2.25. 2.25 times 3 will give me 6.75. And 6.75 times 3 will give me 20.25. So if I were to graph that, I would start at 0.25, which is going to be way down here. This is counting by twos. Then I'm going to go up to 0.75, which is still less than halfway. Then I'm going to jump up to 2.25. Then 6.75, which is almost 7. And then I'm jumping up to 20.25. I'm going to go way up here. So you'll see I have quite a quick growth. And that's what those exponential functions do. They grow really quickly. Let's look at this next one. Starting at 18, but my factor of change is 2/3. So my first point will be at 18. Then I'm going to multiply by 2/3 times 2/3. That will give me 12. 12 times 2/3 will give me 8. 8 times 2/3 will give me 16/3, which is 5 1/3. 16/3 times 2/3 will give me 32/9, which is going to be 27, 5 repeating. This will give me 5.3 repeating. So I would start at 18. At 1, I would go down to 12 already. 2 will be 8. 3 is going to be 5.3. And 4 is going to be 3.5-ish. A little bit higher than that. And you'll see again, it's decreasing, it's curved downward. And it'll keep approaching this x line, but it'll never touch it. That is an exponential decay. So how can we look at an exponential function and tell if it's growth or decay? Well, it's all about this factor of change. If this factor of change, right here, 2, 3, if that's greater than 1, it's going to be exponential growth. If it is less than 1, it's going to be decay. Doesn't matter what your starting point is. It's this number that matters, your b. If your b is greater than 1, growth, less than 1, decay. Okay, let's look at this, decide whether it's linear or exponential. For both of these, we can find our y-intercept. So when x is 0 here, my y-intercept is 2. But what's happening here? What's my pattern? Well, you might originally think it's times 3, but immediately that doesn't work. Then you'll see, oh, it's plus 4, plus 4, plus 4. If we have that constant addition, we have a linear equation. So this would be y equals, my slope is change in y over change in x. So this is 4 over 1, or 4x, plus my y-intercept, which is 2. You can plug it in. 4 times 0 is 0, plus 2 is 2. 4 times 1 is 4, plus 2 is 6. 4 times 2 is 8, plus 2 is 10, etc. Okay, let's take a look at this one. Here's my y-intercept. When x is 0, y is -1. What's our pattern here? Well, you'll quickly see that my pattern is times 3. So this is a multiplication pattern. Therefore, it is exponential growth. So y will equal a. That's my -1, my y-intercept. times my factor change, 3 to the power of x. Okay, let's look at these examples. These are all exponential, so that's given to us. So we're going to use this format. Well, what's my starting point? When I forgot to have my pen on, that will always cause me trouble. When x is 0, my y is 2. So that is my starting point. That's my intercept. And what's happening here? Well, it is times 7 times 7 times 7. So it's 7 to the x power. How about over here? What's happening here? Well, my starting point is going to be 64. And you might say, oh, I'm dividing by 2. But remember, this is multiplication. I can't put a 2 here, because if there's 2, then this would be going up by 2, which it's by times 2, which it's not. So what's the same as dividing by 2 or multiplying by 1/2? So this is exponential decay. Y equals 1/2. That's 64 times 1/2 to the x power. Okay, how about this next one? Here's my starting point. That is at 7. And it looks a lot like times 2 times 2 times 2. So those aren't so bad. Okay, I have an ice bucket challenge here. It says that it starts with one person completing the challenge. They challenge 3 friends to do the same. Each of the 3 friends then challenge 3 of their friends to do the same. It says let's create a table. We started with just me. I just started it. I had one person completing the challenge. And then I had 3 friends and then each of their friends had 3 friends, and so on. So if you think about this, here's me completing the challenge, and I had 3 friends, friend A, B, C. So there's my 3 friends. Now each one of these people had 3 friends. See how we went from 1 to 3 to 9? So it grows pretty quickly. So what's my function? Well, I started with 1. And then we increase by 3 each time. So just a summary. Our exponential function rule is y equals a times b to the x. So a is our y-intercept when x is 0. That's where our function starts. B is our constant factor of change. That is what we're multiplying by each time. And our exponent. Let me know if you have questions. You know where to find me.